Hello and welcome back to Psychology 301. This is Dr. Williams and this is the lecture for Unit 1C. I want to talk a little bit about other non-associative processes other than reflexes and fixed action patterns. And the two that I'd like to talk about are taxis and kinesis. This is going to be a fairly short lecture. I only have 8 slides, and so it should be pretty quick. So taxis and kinesis are behavioral learning processes in which that affect movement, that help organisms find a more optimal environment. So if a critter finds itself in a bad environment, the bad environment is the stimulus that prompts movement, and they start to move. Taxis is a directed form of movement in which the organism is either moving toward or away from a specific stimulus. So, for example, moving toward warmth or away from heat. That might be, it could be either of those, right? Kinesis, on the other hand, is undirected movement in which the organism simply starts to move. If the environment becomes suboptimal, they start to move, and they move until the environment gets better or until they move themselves into another location. But it's not directed. They're not going toward or away from anything. They just start moving. And I'll give you some examples. Let's talk about taxis first. So positive and negative taxis are types of taxis where you're moving toward or away from the stimulus that you're looking for, that would represent either a better environment or moving away from a worse environment. So positive taxis is movement toward a stimulus in the environment, and negative taxis is movement away from a stimulus in the environment. And typically we're talking about a stimulus that's relatively constant and relatively continuous, and so the organism works to get closer to it or to move away from it. So let me give you some examples. Fly larvae. Flies will lay their eggs on top of dung. So when you go out into a field, like a farm field, and walk around, if there's cow poop and you get close to it, you'll notice that there are flies on it. And the flies will lay their eggs on this dung. And when the fly larvae hatch, they burrow into the dung, away from the light. The light will dry them out, and so they're genetically selected to move away from light. It's called negative phototaxis. Taxis referring to movement, referring to light, and negative, that they're moving away from the light. On the other hand, honeybees tend to fly toward the light. They have positive phototaxis. If you put a bee in a darkened environment and there's a window, they'll fly out the window. And you can get types of taxis. You can get positive phototaxis in a plant. If you put a plant in a cardboard box and cut a hole in it and set it out in the sun, the plant will actually grow out through the hole. It'll grow toward the light. So plants are positively phototaxic. The other kind of behavior is kinesis. And kinesis is undirected movement, which is initiated when the environment becomes less than optimal. The movement stops when the environment gets better. There's no directional intent, it's random, and so you don't want to confuse these two. Taxis is directed movement and kinesis is undirected movement. And an example of kinesis, great example, a fish in the bottom of the boat. If any of you have ever fished, when you catch a fish and pull it in the bottom of the boat, what does it do? It starts to flop around because it doesn't have oxygen. That flopping behavior is an example of kinetic behavior that comes because of a lack of oxygen. And if the fish is lucky, flopping around in the boat, they flop out and they get away. Hooray for the fish, it gets away. That would be awesome. So with these 4 behaviors, we now have improved, we now have a critter that is genetically determined to be able to respond to stimuli in the environment. It can use reflexes. It may have fixed or modal action patterns. It could have taxis and kinesis. And so our little critter that we now have that we're going to work on can respond to very simple changes in the environment. It's not very sophisticated, but it does have a basic foundation for the behavior for survival. It does have a few behaviors that can help it to survive. It certainly would survive better than organisms that don't have any of these behaviors. Under most scenarios, these behaviors help our little critter to adapt in valuable ways. But one of the questions that I have is, what happens when the stimulus that causes a reflex happens over and over and over and over and over again? Do we just keep responding until we're fatigued and we can't move anymore? And then what happens if a predator comes around? So what happens when relatively harmless repeated stimulation that produces a reflex? Is there a way for us to allow our critter to adapt to harmless repeated stimulation? I'm going to stop there because I want to start the next section in the next lecture. So this is a really short one, only about 6 minutes. So have a great day, and we'll see you back for Unit 1D.